Hi, in this video lecture, I am going to cover the topic analysis of trusses. So you can see trusses in many places. For example, in bridges or in many buildings, this type of structure that is known as truss is used. So why we use truss? Because if you use truss, then you can reduce the total weight, and because they are lightweight, so their transfer from one place to another place is easy, and they can also reduce the cost and several other benefits they provide. So here the truss is used in building a house. In the truss we use straight bars, and by combining different bars you get the whole construction, and this whole construction behaves like a single structure. So a truss can be made from wooden bars or steel bars. So if you want to means achieve a high strength, then you can use steel bars in place of some wooden bars or some alternate options. Okay, so here if you put some means plastic sheets or metal sheets above the bars or truss, then you can build the very beautiful design of your home or bridge or any construction. So what is truss? So a truss is a structure composed of slender members joined together at their endpoints. The members commonly used in construction consist of wooden struts or metal bars. In particular, planar trusses lie in a single plane and are often used to support roofs and bridges. So a long definition of truss is provided here, but let's focus on some keywords. Okay, so the first one is that this truss will be composed of slender members. Okay, so this is one keyword that is important for us. So this slender member means that the length of bar should be very high as compared to the cross sectional area. Okay, then joined together at their end points, that is obvious thing. Then the members commonly used in construction consist of wooden struts or metal bars. That is also we have discussed in the previous slide, that the bars may be of wooden or plastic, or it may be of metal pieces. So as per your requirement of strength, you can choose the material. Then, in particular, planar trusses lie in a single plane. Okay, so often you will see that the trusses are constructed in a way that they are lying in a single plane. That means they are planar. But often you will see that okay, and this type of trusses are often used in the roofs and bridges. Now move to the next slide. What is the objective of analyzing a truss? So in this topic we will analyze a truss. So why, or with what objective we will analyze? So our objective will be to determine the forces and their magnitude of forces. So here we can write magnitude of forces and direction of forces. Now move to the next slide. So there exist three methods. The first one is method of joints, second one is method of section, and third one is graphical method. We will not use this third method. We will just use these first two methods for determining the magnitude of forces in the members as well as the forces acting on the supports. So there are several assumptions. That means this method of joint or method of section that you will use, they will not work for some exceptional cases. So here again the definition of truss is given. So now come to the assumptions. So the first assumption is that the bars should be connected at their ends by frictionless hinges. That means if in your truss, okay, the ends like this, okay, if these ends are not connected by frictionless hinges, then you cannot apply the two methods, or means methods of joints or method of sections. To in order to apply these two methods, your truss should be made of members and frictionless hinges. All the bars should lie in one plane. That means these two methods are valid for planar truss only. Planar truss. Okay. So if you want to analyze a three-dimensional truss, then you cannot use method of joint or method of section. These two methods are valid for, or in our course we will analyze only planar truss. Then the forces acting on the bars are applied at the hinges only. That means the forces, suppose we are applying a force here, that is acceptable. We will not apply force over here, okay, or at this place. In these ways, that means forces at some offset point from the joint will not be acting in your analysis of truss problems. Okay. Then fourth assumption, the forces must act on the same plane of the bars. That means we are considering planar truss, so forces should also act in the same plane of the truss. Okay, so the plane of forces should be same as the plane of truss. So these are four assumptions, major assumptions that you should keep in mind while solving any problem related to analysis of truss. Then there exist three types of mechanisms, or three types of combination of links. Okay, so suppose you got this type of combination of link where there are four bars or four members. This is the first member and you are naming it AB, and then there is another member, its name is BC, and there is another member CD, and this one is AD. So these are four members, and the point A connecting this AB member and AD member is hinged. Okay, so you are providing hinge joint at this uh, A point, and you are providing a roller support at the point D. Okay, then in this combination of link, if you apply any force at this point B in this direction, then what will happen? This four bar mechanism or four bar combination of links will get deformed, and finally it may take this kind of shape, or if you apply excessive force, that means it will continuously deform, right? So this combination of four link cannot sustain or cannot resist this force P acting on the point B. Okay, so if you get this type of this type of structure where the structure is not able to bear or resist the external force, then you will call this type of mm, frame as deficient frame. Okay, so this is called deficient frame. Okay, and now suppose we are adding another link connecting the point B and D. So this is another member. Now you got five members to make this frame. So now if you apply an external force at point B, then what will happen? This frame, now it can resist the force P. So applying this force P will not produce any deformation until the frame is safe, or until the frame is not failed. Okay, so this type of frame will be termed as, what we call it? We call it perfect frame. Perfect frame. Okay, now suppose we are adding another link to connect the point A and C in this way, then will it provide any further rigidity? No. This frame is already rigid. If you applied only this link BD, in that condition itself, the frame was stable or you can say the frame was able to resist the external force. Now this another or this extra member AC AC is basically a redundant member. Okay, that means this AC member is not required to provide any rigidity to this frame. Okay, so this kind of frame or this kind of arrangement of members is known as redundant frame. Okay, hope these three types of frames are clear to you. Now next let's move to the another concept. Okay, so let's suppose you there is a problem where the number of members, okay, suppose there is a complex problem and you need to solve it, and the number of members in that problem is very large. For example, okay, suppose this is the problem, and this frame consists of many number of members. Okay, suppose there are more than 4 number of members. So how you will determine that this frame represent a deficient frame or a perfect frame or a redundant frame? So to find out the type of frame for a complex problem, you can use this formula. The formula between n and j. What this n signifies? This n means number of members in the frame. Okay, so if you represent the number of members in frame by the variable n and number of joint in the frame by variable j, then if the relation between n and j is like this, n is equal to 2j minus 3, then it will represent perfect frame. Okay, and if number of member is less than the value 2j minus 3, then it will know it will be called as, or it will be termed as deficient frame. And if n is greater than 2j minus 3, then we'll call it redundant frame. Okay, now another most important thing, you can solve a perfect frame, but you cannot solve a redundant frame. So because of that reason, this perfect frame is also termed as statically determinate frame. Okay, so using these method of joint and method of section, you can solve statically determinate frame, but you cannot solve statically indeterminate frame. So this these terminologies are important, so you can remember them. Now let's move to next concept. Okay, so suppose this is example and you are asked to determine the type of this frame, whether it is a perfect frame or it is a deficient frame or it is a redundant frame. Then how you will determine? Okay, so now count the number of members in this frame. Okay, so let's start from this member AB, and if it is member number 1 and this AC member is member number 2, BC is third member, and this CD is fourth member, DE is fifth member, and EF is sixth member, and FG is seventh member. This BD is eighth member, DF is ninth member, and CE is 10th one, and this EG is 11th member, then n will be equal to 11. And now count the number of joints. So here you have first joint, second, third, fourth, fifth, sixth, and seventh, right? Okay, so j is equal to 7. So now if you apply n, if you calculate, means if you calculate, now let's calculate 2j minus 3. So this 2j minus 3 will be equal to 2 7 14 minus 3, that means 11. So in this case n is equal to 11 and 2j minus 3 is 11. That means we can say that n is equal to 2j minus 3. So this frame will represent a perfect frame. Perfect frame. But suppose you have removed one frame. Suppose you are removing this frame CE. CE. Okay, we are removing this frame CE. Now what will happen? This frame will become redundant or deficient. Let's find. So now this n will be equal to 10 and j will be equal to how much? Again 7, right? So in this case 2j minus 3 will be 11 and n is equal to 10. That means n is less than 2j minus 3. And in the previous slide we had seen that this condition represents deficient frame. Now let's take another condition, and in this condition suppose we are adding one more link, and we are also using this link CE. So in addition to the existing frame, we are adding one more member between A and D. So in this situation, our value of n will become 12 and j will be equal to 7. So 2j minus 3 will be equal to 11, but n is equal to 12. So here n is greater than 2j minus 3. So this condition will represent redundant frame. Okay. So in this slide, we learned that how we determine that if a frame is a perfect frame or deficient frame or redundant frame. And we used the formula between n and j. N is number of member and j is number of joint. Okay. Now let's take one example and try to apply method of joint. So we will learn this method of joint in our next session, next video. Now we are going to close this session. Thank you.